Alright, welcome back. We're looking at solving trigonometric equations, and we're going to look at a little bit more of a complicated problem right now. If I have 3 cosine theta plus 9 equals 7. So for this problem, I don't just have a trig function equaling a number. I actually have some other things occurring to cosine of theta. But we're actually going to use some of our algebra skills, just like we did in the past. I'm going to isolate the cosine of theta. Alright, so I'm going to move everything else away. You could even imagine if this was just an x, if it said 3x plus 9, how would you have gotten x by itself? Right, we'd want to move this 9 and that 3 in order to do that. Alright, so that's the first thing we're going to do, and then we'll have a problem similar to the previous example. So step 1, let's subtract 9 from both sides, and I will have 3 cosine of theta equals -2. And to get rid of this 3 that's being multiplied by cosine, I would divide both sides by 3, and I would get cosine of theta equals -2/3. Now, in order to solve for theta, alright, we can consider the graph of cosine, alright, which, if this is my pi over 2, here's my pi, 3 pi over 2. Did I give myself enough room? I think I did where you guys can see this. Cosine, once again, like sine, will oscillate between the values of 1 and -1 for its range, and it does exist between -infinity and +infinity for its domain. But if I'm looking at just one period or one cycle of cosine, it starts up at 1, at 0 radians or degrees. At pi over 2 it comes down to 0. At pi it's down to -1. 3 pi over 2 back up to 0. And at 2 pi it is there. So the curve would look something like this. And it does repeat infinitely. However, one period of cosine, one cycle where it hits all of its marks, does occur between 0 and 2 pi, or 0 and 360 degrees. Alright, so if I want to find out when is cosine going to be -2/3, -2/3 occurs somewhere down here. And notice I'm expecting my solutions to occur somewhere between pi over 2 and 3 pi over 2. But first, to find my reference angle, I'm interested in the values between pi over 2 and pi. Or actually, technically my reference angle would be a positive number, but we'll find this solution here first. And cosine is in fact, notice, agreeing with our graph. Here's the first quadrant, here's the second quadrant, third quadrant. Right, cosine is in fact negative in both the second and third quadrants. Right, so that should be familiar to us. And here's the fourth quadrant here, where it comes back up and is positive. So if I'm having a cosine of an angle equal to negative, I would expect my solutions to occur between the second and the third quadrant. So in order to solve this, I would be taking the cosine inverse of both sides, and actually I'm just gonna try to leave room where your work and my work will make sense when we look back at it later. So we would take the cosine inverse of both sides, and recall cosine requires the input of an angle, and it gives us a ratio, whereas the inverse functions require the input of a ratio, and it will in fact be giving us back an angle. So this input does make sense for a cosine inverse. So cosine inverse of cosine cancels out, and I'll have theta equals the cosine inverse of -2/3. And when I plug that in, actually, let's see. What I would actually probably, let's see. As I said earlier, the reference angle is going to be the positive version within the first quadrant. So it's actually easier if we plug in the positive value to find our reference angle alpha. So I'm going to plug in the 2/3 as a positive number just to figure out the reference angle alpha first, and then we'll be able to use that to figure out these angles here. So alpha is going to be the cosine inverse of 2/3, which will be, and actually I'll even label that as alpha. Cosine inverse of 2/3 is about, let's see, approximately 48.2 degrees. And in order to get that from a calculator, you'd have to make sure you're in degree mode, right? So, so my reference angle is 48.2 degrees, is where this would occur. And I now want to figure out, where do these 2 points occur? So what I'm going to do in order to find those is add and subtract 48.2 from pi in order to find those two angles. So my theta can either be, well, actually we'll work with degrees this time, so 180 minus 48.2, or theta would equal 180 plus 48.2. And so I do this math here, and I will get theta. Actually, these are approximations once again. It's not exactly 48.2 degrees. So theta is about 131.8 degrees, or theta is about 228.2 degrees. So these are going to be my significant angles, all right, the significant solutions of this problem that occur within one period of cosine. Now when you solve these problems, your graph does not have to look as fancy as this. They can be much simpler, just to get an idea of which quadrant your answers are occurring in and things like that. And just to use as a reference, does it make sense, right? So 131.8 degrees would in fact land between 90 and 180, and 228 would in fact be in our third quadrant, which is what we would expect. And we could even actually plug these back in the original problem and do a check. If I did cosine of this angle multiplied by 3 and added 9, it should be about 7. And once again, we have to consider the error based off of the approximation that we had. And once again, I'm not interested in just these two solutions. I want to know all of the solutions every time that it's equal to that, because this graph is going to come back down and it's going to hit infinitely many times on the curve. And the way I can do that is by figuring out what are the coterminal angles with that. So that would be 131.8, and I could add, and to find a coterminal angle in terms of degrees, I would be adding 360 degrees, right, one full circle, and multiply by n. Or I would, for this angle over here, do 228.2 and add 360n to find the coterminal angles there. And these would be all possible solutions of the original equation. Alright, so that's a problem with cosine. And I'm going to actually do another example, which will be an optional one, just for a problem that isn't sine or cosine. I think sometimes the other trig functions we're less familiar with and can cause some problems. And there are some problems tonight on tonight's homework that will require you to use some of the other trig functions. But they all follow the same general idea. Alright, see you next example.